I am R&D manager in Eltek. This is an Italian company that it is developing and producing components for automotive products and in particular for SCR systems. So, SCR systems, so good afternoon everyone, first of all. SCR systems are widely used to reduce diesel engines emissions. Nevertheless, we all know that low temperatures are an issue for all components as they cause liquid AdBlue to freeze. Eltek has developed a portfolio of solutions, a portfolio of sensors and devices that can be used in such condition. We call these solutions in-ice solutions. In the following presentation, I will speak about Eltek experience with AdBlue. I will describe our in-ice technology, and in the end, a few words about sensing integration and future steps. Eltek and AdBlue, a 15-year story. AdBlue is really a tough media, but it is something we got to manage thanks to our 15 years long experience. We began with the first product, to develop the first product in 2001, more than 15 years ago. Then, step by step, facing the problem related to AdBlue, we had the opportunity to develop a portfolio of solutions with unique features. The first product in the market was the temperature sensor in 2005, then the pressure sensor in 2008, and then pressure plus temperature, and finally, last but not the least, level and quality sensing technology. I go now more in detail, speaking about our in-ice technology for SCR sensing devices. Eltek sensors cover a wide range of sensors needed by SCR systems. Pressure, temperature, level, quality, and finally the combo sensor, level plus temperature plus quality. Each sensor has got a specific characteristic in cold condition, and we call this characteristic in-ice feature. The pressure sensor does not break even at minus 40 degrees. This is simply the in-ice feature. Even if our sensors are responding to market demands in terms of performance, we are following our roadmap to improve sensor technology and at the same time reducing both cost and size. Gen 1 is the sensitive element already used in our pressure sensor. Generation 2 is already in the market, approved and available in the market, and it means basically the integration of all the electronic components on the ceramic peel. And also it means digital output available. Gen 3 is focused on reducing the size of the sensor, and it is in development today. We are already working in our research on Gen 4. More than 15 million vehicles are equipped today with Eltek pressure sensors. We produced last year more than 4 million sensors, and we are going to exceed 5 million sensors this year. The sensor is suitable for not only for passenger cars and light-duty application, but also for trucks and for off-road application. It is available with both analog and digital output, and on the digital output, it is possible to send out for free also the temperature measurements. So, among the other characteristics, I can highlight that it has been approved according standard requirements for AdBlue applications. And I can say, for instance, 1,000 freezing cycles and 4,000 hours in AdiBlue at 90 degrees. These are our tests that we did on the sensor. These are the standard vibrations and mechanical shocks test. Level and temperature sensor. When we began to develop this sensor, we took in account the limitations of existing solutions in the market, like ultrasonic, radio frequency, reed switch. The sensor is able to measure the level even in frozen AdiBlue, and even when the AdiBlue is in mixed phase. If you look at this picture, you can see that we can measure when the AdiBlue is fully fluid, fully liquid, or when it is fully solid, or even when it is stratified, so layers of liquid and frozen AdiBlue. We can even measure a layer of air in between. So it means that we are able to detect air cavity that are quite common during the thawing phase. It is also possible, thanks to the principle, measurement principle, is also possible to detect the refilling of liquid AdiBlue on frozen AdiBlue. The principle is a contactless capacitive principle. In the sensor are produced a layout of electrodes, discrete electrodes. Every electrode is like a capacitor able to understand the presence of a liquid. It is available in different lengths, and it is basically not affected by AdiBlue parameters like conductivity, concentration, permittivity, and density. It is also not sensitive to air bubbles. We say also that it is working without blind zone. It is basically due to the fact that we don't need any reference on the foot of the sensor. And so the first electrode is able to measure. Our features are the standard diagnostic features and standard custom digital output like cent, lean, and cam. The accuracy is, of the current product is plus minus 2.5 millimeters. A new version is under development with the target of plus minus 1.5 millimeter. Standard diagnostic features, standard operating temperature for these systems, minus 40 to plus 80. It is protected also for track application up to 48 volt, and it is protected up to plus minus 25 kilovolt ESD discharge. About the assembly, it is possible top down or bottom up by means of several fixing solutions like bayonet, screwing, or welding process. Welding because the plastic material used for the sensor is HDPE, the same used for most of the tank, so it is possible to have a direct welding of the sensor on the tank. SCR quality sensor. This sensor needs only a thin layer of AdiBlue to work, to operate. It is basically needed only an AdiBlue drop on the plastic surface to have a measurement, to measure the concentration of this drop. It is based on an optical principle. The critical angle is related to the concentration of AdiBlue itself. Accuracy. Accuracy is in the main range, so between 20% and 40% of urea in water is plus minus 1% beginning of life, plus minus 2% end of life. About the temperature sensor is plus minus 1 degrees. Resolution is 0.1% for concentration detection and 0.5 degrees for temperature detection. The sensor can also detect tampering, so when some wrong fluids are inside the tank, like fuels, salt water, engine coolant, oil, and so on. The measurement is a continuous measurement, and I would like to point out that the sensor, thanks to the optical principle, is able to work not only in static condition, but also in dynamic condition. So we will see later that it is suitable for inline assembly, not only for in-tank assembly. So our characteristic, like the output signal, that can be analog or digital. It can be digital sent or digital canned for track application. It has been approved according standard test for SCR application. And it has been also tested for dynamic assembly, for inline assembly, up to 15 bar. The accuracy, as said, has been proven during after our validation test that it is clearly less than plus minus 2%. We also did test to understand, to demonstrate that the sensor is not affected by turbidity. We tested it according ISO 7027 and using Arizona dust fine. We can speak now about the assembly. The assembly, it is possible in tank. This is a standard assembly for passenger car application. And we can use several kinds of assembly method, like screwing, hot plate welding, and bayonet. As said, the sensor is suitable for inline application. We have a collaboration with the company FOSS to develop these innovative sensors for the market, and it integrates also a heated pipe system. We are also developing now a submarine application for truck application. Submarine means that it is sealed, so we can put the sensor inside the tank. And this is only an example where the sensor can be put inside the tank, inside the sensor unit. SCR combo sensor. It responds to the needs of integrating more function. In this case, we integrate all the in-ice function that we saw below. So we are speaking about level, quality, and temperature all in one device. The in-ice feature in this case are the same that I already explained you before for the standalone sensors. I'm going now to describe our in-ice technology for SCR smart heating. We developed this new product thanks to our experience with nanomaterials. It is basically a plastic material with a PTC effect. This material can be molded like a standard thermoplastic. So we can use injection molding, compression molding, all the processes that are normally used for thermoplastic material. Thanks to this fact, we can mold the plastic heating material in countless shape. The PTC effect is also local. It means that the portion of the device that it is not covered by AdBlue is self-protected in both power and temperature. We can also reach quite a high power density. Coming to some more detailed explanation, the power density is up to 1 watt per squared centimeters. And coming back to the main feature that we can produce countless shape with this plastic, The plastic itself is the heating element. It is not a single sources like PTC stone, but it is a distributed heating. For this reason, we can reach a very efficient thermal exchange. SCR sensor unit. It is the integration of all the in-ice solution in one device. Level, quality, temperature, and heating. I forgot pressure. But it means not only a high level of integration, it means also system responsibility for Eltek. And we estimate a very big impact in terms of cost reduction. Our in-ice solution have been developed for SCR application, but basically we can use this solution for all the systems where there is a fluid that can freeze. So that it can also be used, for instance, for water injection application. Water injection is a new technology to reduce gasoline engines emissions. In this case, the fluid is not AdBlue, but it is the ionized water. And the ionized water can freeze, and I can also highlight that it can freeze more often than AdBlue, because at around 0 degrees, it begins to freeze. Our portfolio of sensors is available and is suitable to be used also for water injection application. I'm speaking about pressure and temperature, level and temperature, and the smart heating technology that I described before. For the quality, it is not possible to use the same principle, so the optical principle that we have for SCR application, because in this case, quality means to detect the ionized water from tap water and not concentration. So that we have developed a new sensor based on conductivity. The sensor is able to measure the conductivity itself. It is not only an on-off sensor. It is able to measure the conductivity. And also, it can also measure the temperature, because it is compensated in temperature. The resolution about the conductivity is 1 microsiemens per centimeter, and for the temperature, again, 0.5 degrees. It is, again, ensured the tampering detection, that in this case means several fluid, but also gasoline and also AdBlue. Sensor can be, again, produced with several auto signal, with it is compensated in temperature, standard supply voltage. The measurement, as I said, it is not on-off, but it is a continuous measurement. In this picture, you can see that looking up the conductivity, we can detect the ionized water from tap water, but also from ethanol, gasoline, and other polluted, other fluid. In the end, a few words about sensing integration and future steps. Thanks to our experience in mechatronics, we are developing systems with a high level of integration, including sensing integration, level, quality, pressure, temperature, but we are also able to produce speed, position, and other kind of sensor to integrate the Eltek PTC technology. If it is needed, also water pumps and water valves, and also the electronic control unit, because we are already in the market with our electronic, already approved from car makers, with in-house developed electronic for both hardware and software. Future steps means not only sensing integration, as I said, but also new devices for fuel cell and for hybrid e-vehicles. To wrap up, Eltek in-ice solutions can operate in any conditions, and always allow the SCR systems to hit the target in terms of emission reductions. In the end, I invite you at our booth next door. We can show you our products and answer your questions personally. Thank you very much.